Okay, Mr. Fleischmann and we will introduce an approach or a framework for handling exceptions in business process management. First, when we are speaking about exceptions in business process management, maybe we could go one step back and consider what are the characteristics of exceptions. When we take a look at some well-known dictionaries, we will see that exceptions are maybe something that is similar to an exclusion from a list of predefined options, or that exceptions are something which deviate from a rule. So just let's keep that in mind when we consider what are the BPM objectives and the strengths of BPM. The BPM objectives are to analyze, to optimize, and if possible, to standardize business processes. The problem here is that BPM is encountering a number of challenges, which are, well, we have an increased flexibility. As a matter of fact, I think about in every presentation I did in this conference during the last years, I claim that. So that's fairly consistent. And we have to live with ad hoc changes, which comes with flexibility. And we have to encounter increased frequency of exceptions. So we have to deal with more and more frequent deviations from a rule. And well, that's obviously a conflict because BPM on the one hand wants to standardize processes in order to make them more efficient. But on the other hand, we have this problem with the exceptions, with the deviation from a rule. Let's, well, so far that was a bit abstract. Let's try to make that a bit more visual. Let's imagine a scenario where an ERP vendor offers a cloud-based ERP systems, a system that targets small and medium-sized enterprises. The normal operational process obviously would involve continuously ensuring the availability of the ERP system, ensuring the necessary support for that system, to continuously make sure that all data is backed, and obviously to regularly bill the customer according to their usage patterns of this system. So that was a normal operation. Typical exceptions are that from time to time the users may lose the security hardware token that is necessary in order to access that system. In order to well, address that problem, the customer just calls the customer support and the ERP vendor sends a new token. Because that happens quite frequently, there's a well-established standardized process. The hardware tokens are already held in a larger store, so we can swiftly, or so the ERP vendor can swiftly provide customers with new tokens. That's one example for an exception. Another example is that a customer encounters a technical problem and contacts the customer support. The service staff uses a checklist in order to have a structured way of narrowing down the problem and resolving that problem. The third example is that very rarely a customer misconfigures the ERP system in a way that the ERP system is not working anymore in the expected way. In these very rare cases, obviously the customer calls first level support. First level support does not know how to resolve that issue. It escalates the problem to second level support, and in some complex cases, second level support might even speak with the developers responsible for the system. So these are the three exceptions or examples for exceptions I would like you to keep in mind, because we will come to these exceptions later on. Meanwhile, from these examples, we can identify or motivate the relevancy for thinking about exceptions in BPM. Sorry. The first one is, well, handling exceptions involves high effort. This is especially true in the cases where a customer has a technical problem or he has misconfigured the ERP system. it's necessary to handle these exceptions, because if you don't handle these exceptions, the ERP vendor very soon will lose customers. And exceptions are quite frequent. Think about losing the hardware-based security token. It happens quite frequently, so this exception is not that exceptional in the stricter sense, because it happens quite frequently. And again, the world is getting more and more flexible. Businesses are getting more and more flexible. So addressing exceptions implicitly becomes more and more important as well. I think that current methods and tools are still focusing on standard processes, because making standardizable processes more efficient is basically the key case for selling these solutions. So today's methods, and particularly the tools, still focused on standardized processes. So that's it for why should we care about exceptions in BPM. I'm sorry. Now let's go to what kinds of exceptions are we encountering in everyday life, or maybe not everyday life, but what kinds of exceptions are we encountering in practice? We would like to propose suggest this classification. This classification basically says we have two dimensions. One dimension is whether the exceptions are predicted or not. The second dimension is about how these exceptions are handled. Is the handling of the exceptions predefined, or are these exceptions handled ad hoc? And in case of predicted exceptions that have a predefined handling, we speak of routine exceptions. We will come back to the examples later, but just bear with me for the remaining two exception classes. If we have predicted exceptions that require some kind of ad hoc handling, because the handling is not completely predefined, we propose to speak of minor exceptions. In the case exceptions are not predicted, obviously we cannot predefine the handling of these exceptions, so we speak of major exceptions, and I think there's no exception type that has unpredicted exceptions with a predefined handling, because if you can't predict it, you can't predefine handling. Okay, so much for the exception classes. Now let's have a look about how these exception classes match to the example scenario given a few minutes ago. The normal operation is something we suggest to call the happy path, the normal flow of execution. And the happy path is not an exception, it's just the normal process. The case where customer loses the hardware token, the hardware security token, is a routine exception, because the handling of the exception is predefined, and we have that exception is obviously predicted. In the case of technical problems, we are speaking of minor exception, because the occurrence of technical problems is anticipated, but resolving these problems is not defined in a complete workflow that defines every step. It's more a checklist, it's a list of tasks that might lead to the goal, but it's to resolving that issue, but it's not a complete, let's say, workflow. In the case of the very rare case of misconfiguring the ERP system, that would be a major exception, because that exception is not expected. The program should not allow such a, let's say, drastic misconfiguration in the ERP system, and therefore we are speaking of unpredicted exceptions that only allow for the exception type major exceptions. Okay, so that was about what are the exception types. Here we would like to reiterate that it is, or to propose that it is really important to distinguish between the happy path, the normal process flow, and the handling of the exceptions that may occur during this process flow. Typically, Process models include aspects that will basically resolve exceptions. So, for example, a order-to-payment process might include specific parts in the process model that focus on how to bring the process to an end when a customer cancels a order. But our suggestion is to externalize this exception handling from the happy path, put it in a different place, because first, it leads to much more easier to understand happy paths, and second, it will simplify using exception handlers that are not using the same modeling paradigm than the happy path. So if we try to handle an exception in a BPMN process directly in the actual process model, we basically have to use the instruments BPMN makes available. If we completely externalize it, we might use completely different instruments. Which of these instruments that might be will be presented in the next part of this presentation. So let's say we have our happy path, our normal process flow, and an exception occurs. Here, because we decoupled the happy path from the exception handling, we jump into some kind of exception handler. In the case of routine exceptions, we propose to use a workflow-based exception handling because responding to this exception can be completely predefined. It might even be automated, and therefore that might be the best solution. In the case of minor exceptions, we propose some kind of template-based exception handling. Template-based exception handling means that we provide some kind of guidance of how to resolve an exception, but we do not force the way how to actually resolve an exception. It's more a suggestion, but it's not forcing the way of how to resolve that exception. In case of major exceptions, we propose to use collaboration, because major exceptions are not predicted. We have to use ad hoc handling, and in these cases, you just have to communicate with the experts at hand. You have to search the experts at hand, and that might be supported by a groupware. Okay, so this was part where an exception occurs and the handler is started. The other problem is, when we are in a routine exception, we might discover that the exception at hand is actually not a routine exception. It just appeared to be a routine exception, but it actually is a minor or major exception. So therefore, it's necessary to provide an instrument for escalating exceptions, like, for example, from a routine exception to a minor exception, from a minor exception to a major exception, or directly from a routine exception to a major exception. Okay. The next part is we have successfully resolved our exception. How can we resume the happy path to the happy path? Well, in order to, obviously the objective is to resume the happy path as fast as possible, but we need to maintain consistency. Consistency means that if for example, when we have an order to a purchase process and a customer does not cancel the order, but an order item from this order, we have to ensure that the actually invoice that is sent to the customer is consistent with the modified order. And how should that be handled? Well, basically, we propose to partition the happy path into multiple smaller exception scopes. And once an exception has been initiated or handled, the happy path will resume at the end of each exception scope. In order to ensure that consistency is met, think about the example I just gave, which was about the modified order should be consistent to the modified invoice. We have to explicitly define consistency requirements the exception handlers have to adhere to. And because we are using exception scopes that partition the happy path, it's much easier to define such consistency requirements and to ensure that exception handlers do not have to adhere to too many consistency requirements. Okay, so that was about, now we have learned about why it's important to think about exceptions in BPM. We learned what types of exceptions might occur, how to handle them, and now I would like to pass over to Mr. Fleischmann, who will demonstrate how this could be addressed with a S-BPM metamodel extension.
Okay. Yeah. Welcome. I have to try to keep you awake. I hope I can do that. Now, Matthias Kurz showed you a classification, how you can consider various exceptions, and you know exceptions are not exceptions, they are normal. And I would like to show you how you can cover a lot of these requirements Matthias explained with our parallel activity specification scheme, which is the basis for the Metasonic products. Here, a short tutorial about parallel activity specification scheme. You have the subjects, you have the messages between the subjects, and sure you know how you describe the behavior of the various subjects. I have a very simple example. A customer orders something and the order is checked by order handling, and then order handling asks the shipment department to deliver the product. And here you have the behavior of two subjects. The customer prepares the order, sends the order to the order handling, then waits for a confirmation, and then after the confirmation, the customer is waiting for the product, and then a similar behavior at customer handling. That's standard, that's the happy path, but the world is different. The customer has the ugly idea to change his or her order. Sometimes it happens. Right? This means the customer sends a change order to the order handling, and order handling checks whether the change is possible or not, and gives a corresponding answer. The order change can be rejected or accepted. And I think this is very important for exceptions. Exceptions can happen or not. And if they happen, you don't know when they happen. And if they happen and they arrive, your reaction is different, depending in which state your process is. And I want to show you that. Here we have the behavior of the customer. We changed it a little. This is what you know. And then in that state, the customer can have the idea, I want to change my order. We describe that with the so-called behavior extension. This means in that state, wait for confirmation and wait for product. These are the red flags. The customer can come to the result, change order. This means this transition is possible from here or here. And then the customer sends to order handling the message change order and is waiting for an answer. And if the answer is order change accepted, then the customer continues the process back to wait for product, okay, then he knows the order has been changed and now I'm waiting for the product. And if the answer is from order handling, order change rejected, then the customer also continues in the state wait for product. Because clear, now he knows I will get the old order. The only difference is if the customer decides here to change the order, then it continues the process here, not here. In spite here, the process has been interrupted. It's not continued here, it's continued here because order change accepted is considered as an order confirmation. It's the same. That's, let's say, a routine exception. That's easy. I know the exception and I can handle the exception. Now, we make it more dramatic. The customer can decide that I do not accept the delivery. I don't want the product anymore, or there's some damages. And we assume that this is not well defined because we do not have a standard handling of that event. This means we add a message mail and a message finished. Mail means I can send everything. You know, mail is that thing you check every day in the morning. Very often you use Outlook. Okay. Here we change that behavior. We have the customer. Now we can handle change order. And then here we have the situation. We wait for the product. We get the product. We check the product. And then we say, no, this is not what I want. And here we introduce another special, we call it another behavior extension. This is a little more complicated, therefore we added a special symbol. We call that behavior the universal communication behavior. This behavior is active only in the state check delivery. This is here. And then this is activated if the customer executes the action reject delivery. And then here we communicate with order handler and shipment. And if that is finished, we go back to state end. This means we jump out of the happy path here, but we will finish it in the end state. And now we have a look into the behavior of that behavior extension. This is this simple picture. It's really simple. You say, okay, we start that behavior if we are in the state check delivery. And then if the customer says react delivery, then we are in that state. And then we say, what shall we do with the drunken sailor? And then we can decide, okay, we send a message or we wait for a message. In our case, we send a message. We say, okay, we send it to order handling. We create the message. The message is created and then it's sent. And then we start again to think about. This means we can send another message or we can wait for messages, and then this means we have a very lively email traffic, and then according to that the subject decide, okay, now it's finished, that's it, we have an agreement, and then order handling is informed that the whole thing is finished, shipment is informed that the whole thing is finished, and then we are in the end state. What you here see, this is more or less your behavior. You have everything in front of Outlook. We have just modeled email behavior what we do more or less every day. And this allows us to integrate, if you can see it in that way, email in the behavior of our process, and this allows us to have a very flexible way to handle more or less unknown exceptions. You can continue that. Now we say, okay, up to now we had a very closed world. Customer, order handling, shipment, we produced some very creative behavior, but now we add the rest of the world. The rest of the world means this is a model of everything which can happen in the world. Here we consider in that subject we can filter, we can start filtering, but let's assume here everything which is produced, every event in the world is created here. This means we send a message, anything happened to the customer, and then the customer reacts on that or not. The same with order handling, the same with shipment, and then anything happened can produce some mail traffic between the subjects and so on. This means this allows us to build a model of unknown things. We expand our model. Now we have standard handler, we have a universal communication handler, and now we have something happened. And that's easy now, because this universal event handler is very simple. It's very close to our universal communication handler, which we say this is active in all states. Then we receive anything happened from our rest of the world. We check whether this is important for us or not. This can be done automatically or by human. And if it's not important for us, we go back to the last state. We just jump back. If it is important for us, we have just the same behavior as we have discussed it before. This means with the parallel activity specification scheme, you can cover many of these aspects described by Matthias Kurz in order to prepare your processes for the non-predictable world. Okay, Matthias Kurz asked some practitioners whether this is necessary and whether this makes sense. And the answer is more or less, during all things, yes, provides definitions that simplify speaking about exceptions. This means we must be able to build a model about exceptions, because otherwise, if we do not have the right language, then we cannot talk about it. And current business process models do not distinguish between happy path and exceptions. There are some, let's say, small concepts which allow that, and then exceptions are mainly handled by IT implementations, but this has the disadvantage: the model does not document your exception handling, and exceptions are crucial for business. This is not an IT problem. Exceptions are crucial for business people. Do I allow that a customer can change the order? And then limitations. I have shown you one approach which allows you to model exceptions, but there are some other aspects which are not completely covered by by the example I have shown you. And here we will do some investigations. Conclusion: exception handling is very, very important, and I think exceptions are the normal. With our is our contribution? We gave a classification of the exceptions. We introduced a procedure model, a general procedure model, how exception handling can be done, and also the related mechanisms. And I have shown you an extension to an S-BPM model, the parallel activity specification scheme, how you can handle that in this notation. I think for the parallel activity specification scheme, only minor extensions were necessary, and these extensions are based on the basic basic methods of parallel activity specification scheme: sending, receiving, and doing. And what you can do, use modeling by restriction. This is what you can do. You can use this very general behavior, and you can say, okay, I want to make a more restricted version how I handle these. Anything happens, and this means you can reduce that behavior. You can say, I do not allow that I send that message to rest of the world, and so on. This means you restrict it, you reduce the flexibility. Okay, that's it. Thank you.
So thank you very much, Albert, for this wake-up talk. And Matthias Kurz also. Thank you very much. Questions from the auditorium, please. Yes, I come to you.
Bravo. Super, Herbert.
Thank you very much for such a fast result. Albert, actually I want to a little bit clarify situation. Traditionally in IT area, we can see that I just especially write out fault, failure, error, malfunction, upset at least. How do you classify all these events in comparison with exception? And is it possible to consider exception as a formalized or generalized situation for fault, failure, error, malfunction? And if so, why shouldn't we consider exception as rare situation and extract the rest? Because the rest is the situation which is calculated anyhow and anyhow predicted.
Yeah, you are right in a certain way. Therefore, I do not like the word exceptions, because exceptions has always the flavor of failure, error, and that's not true. It's not a failure, it's not an error. I think the customer has the right to change the order, right? And therefore, we are looking for a good word.
Yes, but if the customer has a right to change the order, that means that it's our fault.
Yeah.
That we haven't predicted this information. And it's nothing new in principle. So where is exception is really begins?
As I already mentioned, exception is for me something you do not know whether it happens or not.
That's a risk.
A risk?
Yes.
It's, yeah, I don't want to discuss words. I only want to say what our assumptions are here. We say you do not know whether this thing happens or not, or this event happens or not. You can say, and when it happens, then you must react. And you react differently depending when this event arrives. For example, if you change the order, it's no problem to change the order if you are still check the order or check the order, then it's no problem. But it becomes more difficult if you have already handed over, or you have already handed over the order to shipment. Then it's more difficult. Maybe that you can say, okay, if the warehouse already works on that order, then you can also change it. But if the product is already on the truck and on the way to you, then you cannot change it anyway. It's not possible anymore. This means depending on when the event arrives, you have to react differently, and you have to describe that. And therefore, okay, you can say errors, failures are also events which must be handled.
But again, I'm simply strictly against exception, because it's not an exception.
It's not an exception.
It's just an event with a certain probability.
Right.
And if we consider the level of the probability we accept for the execution, then we consider all the events in this gap.
Mm-hmm.
And with a certain probability, we are not considering the certain events. That's our mission. That's our position. That is clear. But it's not an exception.
It's not. I agree with you. It's not an exception. Therefore, Florian Strecker, where is he? He prefers the word God.
Thank you very much. Another question here in the upper part of the tutorial before I go down.
Do you think it's reasonable to have some kind of statistics with your exceptions, so that, for example, if one exception occurs more often in the API process, that you have to decide whether you have to split the process into two processes, for example, I don't know, ordering something beyond a certain amount of money and under it. So, is there any way to do it with Metasonic, like by itself, to see how often a process goes the regular way or not?
Yeah, it makes sense to have statistics. How often certain events, I do not want to use the word exception anymore, how often certain events arrive. And I think here, if you have, let's say, predictable exceptions like change the order, predictable events change the order, then I think it's normal. This can happen 30-40% of all process instances. But if you have to react on something happened in 30% of the cases, then something is wrong with the process, I would say. This should be.
Thank you very much. Next.
Oh, I need to go with the exception. If you want to write a program, you can write each program so that there would raise no exceptions. But it's very complicated to do this, and in this case, you must imagine all these situations, what is to do. If we don't do this, because it would be very too complicated. Therefore, I think we can plan processes without any exceptions.
Sure.
Without any situations which are not planned. But we don't do this because we are not sure what to do in these situations. And thus I think the expression exception is the right word. It means that this situation is not planned before. And if this situation arises, you must plan it, how to do. And situations, exceptions can arise that if you can detect it by the software, by some rules, but they can be detected by people. If you see this is the wrong number on this, and so I think the real case there is, in the case of exception, you must start a new planning for this. For this situation, for this single situation.
That's true. You can start new planning, but what I have shown you is that you have a behavior, a general behavior, which fits to each plan you have. This is what I have shown you. And this allows you to document it. And by the way, this event handling does not extend during complete. Sure, you can describe everything with the flowchart if you want. But I think this is the answer of a mathematician. Here we are engineering, and engineering means we must know there is a solution, and the solution must be transparent and simple. And this is a way to add event handling, the unpredictable, to the happy part. And you just say, I allow the interruption here and here and here, and if that interruption arrives, I handle it that way. If somebody is familiar with assembler programming, these persons, they know that mechanism. It's called interrupt handler.
Thank you. The next question.
Then why don't you just ignore the happy path and model everything with the experts? It's a valid, I'm saying it seriously.
Sorry, I couldn't catch.
You can just forget about the happy path and model everything with the event handler, which might create much better processes, maybe.
Yeah.
More flexible. So why happy path is necessary?
Okay. For example, if you can consider the happy path as one event handler. Yeah.
It is just another exception.
Yeah, the problem is that you say, okay, the happy path is, you need a basis. You need at least one happy path, and this happy path can be one state. Sure. And in that state, you just have event handlers. But normally you want to know for pragmatic reasons. From a theoretical point of view, you are right. From a pragmatic point of view, you want to describe what you are dreaming about. Right? This is the happy part. This is what you are dreaming about. You are dreaming about that the customer orders something as much as possible, and you handle it and you deliver it, and you just wait for the next order. He will not change the order. He will not complain about the delivery. This is what you're dreaming about. And this is the happy part. And you want to document your dreams.
Thank you very much. Another
this
question?
is, from a theoretical point of view, you are right.
Thank you very much. Yes, I see one.
I would like to make one thing sure. So you're modeling the exceptions, or whatever you want to call it, in the happy path, or the model of the happy path. Is that right?
Yeah, but you can also have exceptions in the exceptions. You can have many layers of that.
Because I was thinking about a kind of second process which is taking care of the exceptions. I don't know, maybe that's a different approach, or am I on the wrong way somehow?
No.
That's possible as well.
Yeah.
Oh, okay.
What you can do, you can jump into the exception handling, and in that exception handling you start a totally different process by sending a message to the first subject in that process, and then you handle that in a very, very complex process if you want to do that.
Okay, thank you.
Last word, please.
I think we could start with a system when nothing is planned, and so all events are exceptions.
Yeah.
I think so. And then, sequentially, we can plan these things which are efficiently can be planned. I imagine there's
This is close to the question here. You can start, let's say, with the chaos. And say, what is the chaos? Many people call it email. This means everybody communicates with everybody whenever he or she wants. And then you say, okay, but here you cannot survive. You have just look into your Outlook account. And then you say, I make some restrictions, especially if you handle something. And then you say, okay, you're restricted, and the degree of restrictions is your decision, is your choice.
This was a very good last word. Thank you very much, Matthias Kurz, on the Fleischmann. I'm happy, I'm proud. We are 5 minutes before the planned end.